In this problem, a pitcher claims that he can throw a .145 kilogram baseball with as much momentum as a speeding bullet. So we want to see if this is a legitimate claim or if this is an absurdity. It says to assume that a 3-gram bullet moves at a velocity of 1,500 meters per second. What must the baseball's velocity be if the pitcher's claim is to be valid? We want to, of course, convert this to miles per hour to see if this makes sense, because we typically think of things in miles per hour instead of meters per second, which is the units that we get. So, trying to see if this baseball can move at a speed that will give it the same momentum as a bullet. Since we have two objects, I'm going to write my givens according to each. The baseball has a mass of 0.145 kilograms. And we need to find out how fast it's moving. The bullet, I'm going to label this then as MB for bullet, and just leave no kind of subscript for the baseball. Of course, I can't label them both as MB. The bullet is 3 grams, and the speed of the bullet is 1,500 meters per second. Now, what I noticed first of all is that there's an inconsistency in units. We have kilograms here, and we have grams here for bullet, so I'll make that conversion to 0.003 kilograms. And then we'll use that. The way that we're going to approach this problem is first we need to find the momentum. So we'll find the momentum of the bullet. Momentum is mass times velocity. So for the bullet, we have the mass to be 0.003 kilograms, and we have the velocity to be 1,500 meters per second. This gives us a momentum of the bullet to be 4.5 kilograms times meters per second. There's no special abbreviation for this unit. We simply take the mass kilograms times the velocity meters per second. So that is the momentum of the bullet. And now we're going to say that the baseball, we're going to assume that the baseball has the same mass, 4.5 kilograms times meters per second, and see what that velocity must be in order to get that amount of momentum. So the same equation here, we don't need to rewrite that again. We have 4.5 kilograms times meters per second for the momentum. Mass is 0.145 kilograms, and we're trying to find that velocity. So we divide, and we get that the velocity is 31 meters per second. Now, again, most people don't understand meters per second. Is that something that a baseball player can actually do, is throw a baseball at that velocity? So we're going to convert this now to miles per hour. So we take 31 meters for every 1 second, and we're going to first convert from meters to miles. So there is, for every 1 mile, there are 1,600 meters. 4 times around the track is 1 mile. 4 times around the track is 1,600 meters. So the meters cancels out. We're left with miles per second. Now we have to convert from seconds to hours. So I know that 1 hour is the same as 3,600 seconds. There's 60 seconds in a minute and 60 minutes in an hour. So 60 times 60 is 3,600 seconds for every 1 hour. So the seconds cancels out, and I'm left with hours in the denominator. I make this conversion, I get 70 miles per hour. So it is a valid claim in terms of professional sports. Pitchers can throw up to high 90s, even some as much as 100 miles per hour. Even in high school. In high school, pitchers can typically pitch over 70 miles per hour. So it has a lot of momentum when you think about it that way, so that's why we always want to wear helmets when we're playing baseball.